Hey, I'm Akash Joshi. I'm the operations research guru, and today we're going to be talking about the Leontif input-output model. And this is basic economy modeling in linear algebra. And in most basic linear algebra courses, you will learn this. I learned it in my Georgia Tech course. So here it is. Okay. So let's look at the problem. There is an economy with n sectors, and we're trying to meet some external demand. Maybe a different country, we're trying to export goods to them and we're trying to meet their what they ask for, and our sectors have to meet this demand. So our sectors have an internal consumption of the resources produced by these sectors. So in our country we use some of the resources in order to produce them and just to use them, and then we send them out to other countries. So we have an output vector called x, and a consumption matrix named c, and a demand vector named d. Okay, let's get into what the model actually looks like. Okay, so here is the model. Basically what this is saying is that our output products minus the products used in creating those products should equal the demand that is required of us. Okay, so let's go through an example problem and see how we can solve such a problem. So here's the scenario. An economy has sectors of coal, iron, and water. For every 100 units of coal, um, for every 100 units of coal produced, this would require 30 units of coal, 10 units of iron, and 20 units of water. For every 100 units of iron produced, this would require 0 units of coal, 30 units of iron, and 10 units of water. And for every 100 units of water produced, this would require 0 units of coal, 0 units of iron, and just 10 units of water. So the demand is 80 coal, 40 iron, and 200 units of water that is asked of us. Okay, so let's look at more into what the vectors and the consumption matrix actually look like for this problem. So our output vector is going to be x, and there are three sectors, each represented by a particular element in this vector. We have coal, iron, and water. Here's our consumption matrix. And once you multiply this by the output vector, you get this kind of format here. And basically what this is saying is that the coal sector requires 30 units of coal, 10 units of iron, and 20 units of water, and so on for the rest of the industries. And if you basically look at this, you can simplify it down to C equals this here setup. That is our consumption matrix. And a thing to note about this is that the consumption matrix isn't 30, 10, 20 over here and 30, 10, and 10 here, because it's not units. There are no units in the consumption matrix. The elements of the consumption matrix are simply percentages. So like over here, that 0.2, all it means is that there were 20 units required for every 100 units produced, and that is simplified into a ratio of 0.2. However, our output vector actually does have units. So yeah. Okay, let's get into the actual solution to this problem. So we have our model here rewritten, and we can factor out this x vector, the output vector, and we get an identity matrix minus the consumption matrix. And of course, we're trying to meet the external demand. Here's our solution. We have this matrix over here, which is the identity matrix. Then we have our consumption matrix. We have the x vector, and then we have our demand vector. The demand vector was right here. So we do I minus c. We simplified that down to this right here. Multiplied by the output vector equals our demand. So if you plug this into a Desmos calculator, Google Desmos matrix calculator, and it can solve it for you. Otherwise, you can solve it manually using row reductions and substitutions. or you can solve it by creating a system of equations and actually solving for all the variables. But I just used Desmos, and it yielded this output vector, this solution for x. And basically what this is saying is you need to produce 114 units of coal to meet 80 units of external demand for coal, simultaneously with 73 units of iron for to meet external demand of 40 units of iron, and simultaneously with 255, you need to produce 255 units of water to be able to meet an external demand of 200 units of water. Okay, that is it for this video. That is the Leontif input output model. So yeah, this is used for basic economy modeling, and of course, as you progress through linear algebra into more complex and complex, um, more complex courses, you are going to encounter different variations of this model that will be useful. Yep. All right, that's it for this video. Thank you for listening. Goodbye.